Today we're going to be talking about Bezier curves. So before we start, I just want to say that that's not really how you say the term. In French, is something else. Term is a French word, but how I pronounce it is Bezier term. I mean Bezier curves. Um, yeah, so that's how you say it, but don't expect it to be right. But that's the topic for today. Anyways, um, we're gonna be talking about that today, right? So, like, what is Bezier curve, right? So, before we even touch that, let's talk about linear interpolation. What is linear interpolation? Basically, pretend that you had a line, right? A line, right, with a start, right, and an end. All right, that's a line, a normal vector. All right, all right, don't mind that. That's disgusting. But anyway, but linear interpolation basically allows us to get specific coordinates based on the percentage we give it, or we give the function, right? So pretend that if we wanted to get the middle, right, of this line, right, linear interpolation will basically give us or return the coordinates in the middle. For example, right, this would be 0.1, all right? So, like in Roblox, what we use this for sometimes is like if we want something to have like a smooth effect to the goal, right? There's something called a lerp, right? A lerp function basically allows us to like lerp through a few points to get to the goal, right? So pretend, so this, like imagine this as like having a start and a goal, right? A start and a goal, a start and a goal, a start and a goal. Let's run with it. Start and a goal, right? Cool. We know this, right? So now let's talk about Bezier curves, right? Bezier curves, right? So basically, the only difference with Bezier curves is that they make curves. It says in the name, they make curves. But like in this video, we're going to be talking about quadratic curves, right? Quadratic curves. So we're not going to be talking about cubic curves or arc curves or all of the stuff, right? There's quadratic curves. So like I'm going to try to make it as clear as possible. I'm not, well, like I'm not really good at explaining things, but I can show you guys, and I want you guys to understand. So pretend that we had 3 points, 1, 2, and 3. What a Bezier curve would do is that if we put in these points, right, to the formula, right, it would basically print out a curve, a nice curve, right? And the curve, right? We know that this right here, the first dot and this dot, right? This is obviously the start position, right? And this is actually, obviously the end position, right? Now, what is this? That's a question. Basically, this point influences the curve. Now, what do I mean, Dawson? All right, pretend that we had the dot right here, right here, dot right here, right, and like this didn't exist, right? This dot didn't exist. This curve would be completely different. It would rather be like this, bam, and then bam, right? This curve is not perfect. Don't literally, use this curve like this. Not perfect, but actually, let me make it better. Like this. Okay, yeah. So like this, right, is gonna be influenced on this point right here. So I need you to I need you guys to understand this because this is gonna be a major thing in this video, right? Bezier curves. Like you have to have a fundamental idea of what it is, right, to do anything else, right? Um, so something else that we're gonna be talking about in this video is this distance, right? Magnitude, right? So what is magnitude? Basically, it's using vectors, right? It's basically just a vector with a starting point to like another point, right? It's distance or the magnitude, right, with the z-axis, right? There's a distance between the end to the start, but we call that magnitude because like usually like identifies the z-axis. So remember that, guys. Remember that this is the vector magnitude is defined as distance, um, and a bunch of other stuff that we will talk about later on. Yeah. Okay. So these are the things that you guys have to understand, right? Bezier curves and magnitude, right? These are the things you guys have to understand. And something else that we might talk about in this video is midpoint. A midpoint was a midpoint. It says in the name, middle point. So the middle of a point, bam, right? And the formula for that we will talk about in the next clip. It's gonna be there. So we're gonna be dealing with magnitude, Bezier curves, Bezier curves. Hopefully I'm saying that right, and midpoints. Okay, see you guys soon. All right, and we're back once again. All right, now get ready. This is when things get pretty fun. Um, all right, so this is Roblox Studio. You guys don't know, and I know that you guys know what this is, but let's start. So first things first, let's make a tool instead of starter pack. The tool basically allows us to hold objects, right? And let's make this a part, right? And let's label this handle, because like every tool in Roblox needs a handle, right? Um, well, like not really, There's also an option that allows you to, if you want a handle or not, you can check it. So yeah, so like we have a handle here, right? And since I wanted to teach you guys how to do this in like filtering enabled, right? Or FE for short, so that it's server-sided too. I'm gonna add remote in here too, okay? So let's add a local script. let's label this as client. Let's make a server script. That's how I like to organize my things sometimes. Let's label this as server. Cool. Now let's add a remote function. Let's fire this as a remote event. This is a tool. All right. Let's say lightning events. Oh my. Okay. Lightning event. Cool. So we have our setup done. All right. We have a handle. We have a server script. We have a client script, local script, and we have a remote event. Cool. Now for the client, we're gonna write this: local tool equals script parent local event for short for lightning event, right? Remember that. Tool wait for child basically waits for that thing, right? So that when the player spawned, right, and like this won't happen, so the player has to equip the tool for this to run. But like just imagine that the client script was executed right way before the part was actually placed in the tool with error, right? So this function right here allows us to wait for that part to be in the game, right? Or like to be in the tool, or yeah, or be a descendant of the tool. So let's do that. Tool wait for child handle, because we want to wait for the handle, right? Handle. All right. Then local. Oh, excuse me. What am I doing? Event. We're gonna wait for the lightning event. Excuse me. Then handle equals tool that wait for child that handle. Cool. We have our setup here. Now we're gonna basically use the activated event in the tool, right? And basically what this does is that every time the tool is equipped, right, and the player clicks anywhere on the screen, right, it's basically gonna fire, right? And it's gonna fire. So we want that. So write this: handle fire server. Then we're gonna need something within these two parentheses. And since we want to direct the lightning, right, to some part, we're gonna need to pass in the part that is hit, right? So in this case, we're gonna have to wait for the player, right, or get the player, right? So local players equals players, then player equals player players dot local player. Bam. We got the local player now. Now do local mouse equals this, the mouse, right? It's gonna get us like the player's mouse, right? And anywhere they hit it. Local mouse get mouse. This basically returns the mouse, right? Player get mouse. Okay, you have that. Now let's do mouse dot hit. Now what is the mouse dot hit return? Let's look in the object browser. We can scroll all the way down to the mouse. Mouse. Here, right here, right, and then hit. What is the return? Current frame of where the mouse is currently hitting by the 3D object. Okay, so this returns the C frame. Okay, this returns the C frame. So we know that, right? What's a C frame? Is basically just coordinates in open space. So X, Y, Z, right? I'll do a video about that very soon, actually. So we know that the mouse dot hit returns a C frame. Okay, we know that. Now right now, our whole client thing is done. This is it. Now we're gonna go to the server. This is where things get a little complicated, but you guys got this. All right, so let's type the same thing we typed in the other script. Local 2 equals script parent local handle equals 2 waits for handle. All right, handle. Okay, and then local lightning events or events for shorts. Tool waits for child lightning event. Okay, cool. Now our whole thing set up. All right, and now we're gonna paste in this function right here, local. This is a direct function that the Roblox developer page gives you, so you can go there. But like, it's basically returning the sum of the quadratic Bezier. That's how you say it. I'm saying it wrong, honestly. But like, it returns the answer from this, like the position or the coordinates, right? So like, this function isn't special. You can legit get this function if you search it up. Oh, let's return the formula for it. Okay. Now we have our setup done, right? Our setup is done. Now what we have to do next? Now for the lightning, right? We need parts, right? So let's make a part function that basically makes the part end, right? And then for this function, I want us to basically return this function, right? Or return the part that we make. So let's do local part equals instance dot new dot part. Okay, now we can legit change any, like, put any color we want in this part, right? If we wanted part dot brick color equals brick color dot blue, right? Or black, let's say, right? We could do the same thing here. Part dot anchored equals true, because if we don't want the part falling down when it's in open space, right? That'll be bad. So local part dot can collide. We don't want the part to collide to us. So we want the part to go through us, right? Our Roblox to go through us. So let's do that. Part that can collide equals false. Okay. Part dot parent equals workspace. Bam. Our whole setup is done, right? Now we want to return this part because we're gonna have to need it later on. Okay, look at that. That's done. Now we want to basically make this line of code actually do something, because right now this won't do nothing, right? If we fire this, like, this line of code is useless right now. We don't want it to be useless. We want it to do something. So let's use the on server event, right? What is the on server event, right? Basically, every time the fire server function is called, it's basically gonna go to the scripts and fire anything within these lines of code, right? So let's clarify. If this function is fired, right? If anyone fires this function, or if anyone uses this function for our server, right? It's gonna go all the way to the server, and it's gonna go and execute these lines of code. Okay. Now, remember when I was talking about how the first argument has like the client player? It's true in this case. Every time you use this function, or every time you use this event, the first argument is always going to be the client player, right? And the second argument here is going to be this, the mouse dot hit. In this case, that's a C frame. So let's do mouse C frame here. Okay. So we have this. Now let's make another function called function lightning, right? And this is where we're gonna do our fancy stuff, our cool stuff, right? So let's make a table called the lurk precision, right? Or pause for short. And we can do that and make it a table. All right, now why am I making a table? Basically what I'm gonna do right now is that I'm gonna use this function, and then after that, we're gonna find the points, right? Then what we're gonna do is that we're basically gonna call it and give it different times, right? So 0, 0.1, 0.2, 0.3. And remember when I was talking about how lines, how this function allows you to go through the whole line, piece by piece by piece? That's what that variable does. So like if we say 0.1, it's gonna go like 0.1 stars forward, right? We say 0.5, it's gonna go all the way to 0.5, right? But remember that the time, it's 0 to 1 all the time. 1 meaning the full vector that's reach, right? The full vector. When we say 0.5, that means half the vector, and etc. Okay, you know this. Now we made this table. Now later on we're gonna use it. Now we want to get the 3 other points, right? So P0 is the origin. The origin in this case is, you guys can say it in your head. 3, 2, 1. It's a handle, right? We want the thing or the lightning to start from the handle, right? Okay, it's the handle, right? Oh my gosh, spelled that wrong. Handle. All right, it's the handle. Now we want to get the end, right? What's the end, right? Where do we want to basically point the lightning to, right? In this case, it's gonna be mouse C frame, right? And the end equals mouse C frame. All right, every C frame has a position property to it, right? So we can do .p. The position basically is X, Y, Z, blah, 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 right? And like it only returns X, Y, and Z, right? If we were to only use a whole C frame, it would return the X, Y, Z, and the angles, and a bunch of octaves, and a bunch of other stuff, that space, that we don't want to go into this, in this video. So let's make it simple, and let's only use the P property, right? Position. Okay, now this is the fun part. Right, now we want the lightning, right, to look like an actual lightning, right? And we want it to have cool curves and stuff like that, right? So we're gonna basically get the curve, right? And I remember when I was talking about how we're gonna use the midpoint formula and stuff like that. We're about to use it right now. So curve, stay with me. This is about to get really confusing. Curve, origin, plus end divided by 2, right? Actually, we should probably put this like this and have 2 other stuff so it looks organized for you guys. So I'll do this, add parentheses, and I'm hoping that you guys know how how parentheses work and stuff like that. So we do that plus vector, we're adding it by a vector because like this is going to return a vector because both of these things are vectors. Yes. Um, so let's do that. Now let's add it to the vector 3. Let's make it random because like we want the spikes to be random, right? So we do. A matter of fact, excuse me. Let's not do that here. Let's just get the curve, right? Later on, right? Right now, right? We're gonna loop through the whole thing, right? The whole function. And remember when I said 0.1 or 0 to 1? We're gonna do 0.1, and we're gonna add the points inside of this function. Lerp position, lerp position dots 1. I usually do this, but like it's very simple. It's basically saying that we have to add one more index into this, right? What's an index? In my last video I talked about it, but an index basically like it's either 1, 2, or 3. It's basically each of this, right? Index. So 1, 2, 3, and 4, blah blah blah, right? If I also do names here, name, this would be the first index, right? It's basically the row or the first or how can I say this to you guys? Basically the first thing or the size of the table, right? So basically right now, right, this is getting the size of the table and it's adding 1 to it, right? So if the table was 0, right, we're gonna need to add 1, right? And the index would be 1, meaning that we could add anything within this first index right here, right? If it was 2, right, if there was 2 things in this table, we would do the same thing. Okay. I don't want to say too much because like, I don't want you guys to get too confused, but let's do this. We're purse, right? And we can add it. Now, this is the time that we can use our function. Quad, the time is I, right? Stick with me, I'm gonna talk about it later on. The starting point is origin, we know this, we talked about it. The middle point is what? The curve, then the end. Good. Now, what is this function gonna do? It's gonna return every single position in the whole vector, right? From 0 to 1, right? And 1 meaning the end of the vector, right? 0 meaning the start of the vector, or the start of the line, right? So now we have this, right? We have every single point in this line, right? But we're not done yet. Since we want this lightning to have a nice curve effect, what I was doing earlier, when I was adding something to the curve, that was a bit wrong. I have to add it here. So like this is gonna return a vector 3, right? And it's gonna return every single point in the line, right? And like if you want the line to be like crazy, right? And like in different positions, crazy, a bunch of stuff, right? To make it look like actual lightning, right? We can add something to it, right? We can do vector 3 plus new math.random. Math.random basically gets random numbers, right? So like in this case, we have an interval of 1 to 3. It's like it's gonna get numbers between 1 and 3, 2.5, 1.1, 1.2, 3, 1, etc. All right, now let's do the same in every single axis, right? So the y-axis, will do the same here. Let's add 3. All right, math.random 1 to 3. The z-axis too. Bam. We're almost done, guys. We're almost done. Cool. Now we have all our points in this position right here, right? We have all our points, right? Remember this part right here? Now all you have to do is actually use it, right? So let's do this. Follow me. All right, for I, right? Let's loop through the whole table, right? Then we can check if the lerp, right? Just stick with me, right? I'm gonna talk about it afterwards. The lerp, I plus 1. If it's not nil, I'm gonna talk about it. Relax. Local, right? Position, current pulse equals lerp. I'm here. I'm still with you guys. All right, that. So now all right. So now what did I do? Okay. Basically, what I did right now is that I'm gonna lerp through the whole table, right? The whole table, right? And basically, I want to check if the last position, right, is there. All right. So pretend that if I was gonna basically do something with the next index, right, or the index next to the index, right? So like if I had 2, 3, 4, 5, 6, right? Pretend that I wanted to use both of these, right, in pairs, right, in pairs. Now, what do you think would happen if I got here? There's no pair after 6, so the thing would nil. Now we don't want the loop to nil, right? That's bad, right? That's gonna error. We don't want that. Therefore, we're gonna check if it's a nil or not, right? And when we check like this, it checks and it makes sure that the value is not nil, right? Okay. Now the reason why I need it in pairs is because we're gonna need to basically connect the lines together, right? Connect the lines together, right? And we need to connect the lines together to actually, build the structure of Lightning, right? So we're gonna need a distance between the last line and the current line. So let's do this. Current line and the future position. The future position equals lerp I plus 1. Oh my goodness, I'm signing. Oh man, my voice is like draining right now. Okay, now we have the future post right here, right? Now let's get the distance. Right, we'll talk about why we need the distance soon. Future position equals current post, right? Position, right? And then we're gonna need to turn this into a magnitude because we're dealing with vectors, and we want to get the z-axis, right? Or singular number, right? And not a huge vector, right? With axes and stuff. So this is gonna do that, right? It's gonna get us the z-axis and everything, right? And the distance between the start and end. Okay, now watch this. Let's local part. Remember that function that we made? Local part equals part. The function part, right? Part is this right here, and this returns a part. So that's going to be a part. All right. Now let's do part dot size equals vector 0.3, 0.3. The z-axis, remember the z-axis, the distance, this case, distance, all right? Now, we want to position the thing correctly, right? So let's do parts dots position equals the current position. Cool, we have that. That's gonna equal the the current position that we talked about a few frames ago. Local, all right, this is gonna be a bit weird. Local dot, not local, part dot c-frame dots. Now we're gonna use the matrix here in a way, right? So part dot c-frame dot position, so we need position in the first two arguments. Equals what? What do you guys think equals? Equals the future position. Okay, cool. Now we're gonna multiply this by c-frame dot new 0, 0. Now we're gonna basically set like each position, right? Each c-frame. So basically we're gonna basically make this negative by negative magnitude. Then after that, we're gonna divide it by 2. So basically fit into the position, all right, or the c-frame in space. Okay. Now look at that. We have this weird looking new function that even I would get confused, right, if I didn't know what was going on. Okay. Now, this is literally all we have to do, guys. This is all we have to do now, right? This is literally it, right? So now let's actually check if this actually works. Lightning. if this nails, don't be surprised. Cause like we're gonna finish together. So lightning, mouse, C-frame. Let's check what happens. All right, but before we start, we need to make a wall to actually actually use it, right? So bam, then bam. Let's do green. Let's anchor this. Let's set. I'll put spawn part right here. Bam, right here. Now let's test this. Set fire server. Okay, I'm dumb. All right, events right here. Let's test. All right, and we're back. And after a bit of debugging, we actually have a nice effect now. Look at that. Look at that. That's sick, dude. That is sick. Look at that. Isn't that sick? That's sick. That's very sick. I'm gonna explain the code right now and how you guys can customize it right now. Let me show you guys. Okay. So I made a tween, right? A tween of object right here, and I played it, right? So what is a tween object? Tweening basically helps us design and change sizes and add effects like bouncing and a bunch of other stuff. Like I'm gonna make a whole video about that later on, very soon. But pretty much what I did was that I used the arguments here, and then I just changed the thing's transparency to 0, meaning that no one could see it. Then I changed it to 1 so that it could be transparency, like so that people could actually see it afterwards, so like players can actually see it. So I did that, then and I displayed it, then it changed it back to 1, and that's pretty much it. And after that, I used this argument right here that reverses it and does it, like 2 times, plays it 2 times. And that's pretty much it. So if you guys want to customize this, just use this right here. Just change whatever property you guys want, like 4, 5, 2, anything you guys want right here. Just change it, and that's it. And I hope you guys understood it. If you guys have any questions, just ask me in the comments. I'm always there listening to you guys and responding. My next video is actually going to be something really interesting. It's going to be about some textures and Roblox and how to gain colors, all them. Because Roblox can support that. So I can't wait to show you guys how to do that. And we're going to be using a bunch of props, site stuff. So I can't wait, and I'll see you guys very soon. Thank you.